wouldn't it be awesome if we could make any OP stack rollup ZK, like fully ZKified? Instead of 7 days, you only have to wait 1 hour. So you basically have 100x improvement in finality, and you kind of get all the benefits of ZK. And with SP1, we realized that was actually really easy. So basically, we took OP stack, and to their team's credit, it's fully open source. It's really well designed. It's super modular. And we took a Rust implementation of their state transition function, and we just took it and put it in SP1 and ran it. And then we have this like super lightweight integration where you can take any OP stack rollup, take the proof of the state transition function, and turn it into a full ZK rollup in like 15 minutes. So it's super easy to do. And now your OP stack rollup, instead of having to wait 7 days for finality and withdrawal, you just have 1 hour finality. So it's like much faster finality, and that's super awesome.
Hi, everyone. Today we have Uma from Succinct. She's the co-founder at Succinct, and they're building SP1, which is a blazing fast zkVM, and we're going to be talking all about it today. So thanks, Uma, for coming on. It's very nice to have you here with us today.
Yeah, thanks for having me.
So I think we can directly get started. I know that ZK has been top priority for everyone. So why don't we start on what you're building at Succinct and why ZK is like very, very important for blockchain scalability.
Yeah, so maybe to start with the second part, why is ZK really important? I think if you think about blockchains today, right, there's this inherent overhead imposed from decentralization. So you have a bunch of nodes all across the world who are having to re-execute all the transactions, and that's why Ethereum today is the world computer, but it's a very slow and very expensive world computer because you have to pay for all this overhead of everyone in the world re-executing stuff. And then ZK provides you this primitive where basically you can verify that a computation was done for much less cost than having to redo the computation. So in this model of the world, you just verify these proofs of execution of transactions instead of having to re-execute them. And what this enables is it enables scaling blockchains. So Ethereum's roadmap is this rollup-centric roadmap where you have a bunch of rollups that are basically executing transactions off-chain, rolling them up, and then settling them to Ethereum. And it's kind of been acknowledged for a long time. Vitalik talked about it, that every rollup's going to be a ZK rollup, and ZK is like how Ethereum is going to scale. ZK is also useful for privacy. So today, like everything on Ethereum or Bitcoin or any of these systems is like fully in the clear. You can see who's sending what transactions. You can see everyone's balance. And ZK additionally has this property where not only can you verify a computation, you can also hide some of the inputs of the computation. And that's useful for privacy because now you can hide, who the sender is or who the recipient is or things like that for privacy use cases in blockchain. So that's why ZK is useful to blockchains. It's useful for scaling and privacy. And in the context of what we're building, so what we're building at Succinct is basically a way to make ZK actually possible for everyone to use. So ZK has long been acknowledged as super useful for these reasons. It's like very obvious, but historically it's required teams of like 30 people who are cryptography PhDs and total experts writing these weird things called circuits to encode your computation in a way that can be proven with ZK. And that's super laborious, requires a lot of specialized expertise, takes a really long time to actually deploy to production. And what we're building is this zkVM, so a ZK virtual machine that's super performant and really fast, that makes it so that anyone in the world can use ZK by just writing normal code. So you just write normal Rust code, you compile it, and then we prove the execution of this normal Rust code. And now ZK becomes basically a weekend project. So you don't need to have cryptography expertise or background. You can just write normal Rust, you write your program, and we can just prove any program. So now making a ZK rollup or a ZK EVM is super simple. You just take things like ref or revm, which is like a Rust implementation of the Ethereum execution or Ethereum node. You stick it in SP1, it's really fast, and boom, you get a ZK rollup like kind of for free. And that kind of applies for any ZK application with SP1. So yeah, our overall goal is just to make ZK like much more accessible to any developer.
Speaking of circuits, my brain just breaks when I start to write circuits. There's a lot of math involved. It's less about like programming the thing to do what you want it to do and just like even understanding how you can use the math to do what you need to do. So I really resonate with let's provide a layer of abstraction for developers, because I personally need that layer of abstraction for sure. But ZK Tech has sort of, I guess, maybe historically been too expensive for mass adoption or mainstream audiences. And we're kind of getting to the point now where commercial hardware starts to make more sense and ZK starts to make more sense. But then there were like optimistic rollups, which were maybe like a stopgap to get us to the point where we can go all ZK. So I guess like where are we with that? And like why? Maybe a good question here would be like, why did they choose to make optimistic rollups when they could have made ZK rollups? And my guess is it has to do with hardware constraints or something like that. But maybe why didn't we just start with everybody being ZK rollups?
Yeah, I mean, so a few years ago when people were building rollups, there was kind of like two flavors. There was ZK rollups where you generate a ZK proof of, Ethereum execution of a bunch of transactions, or with optimistic rollups, you kind of post a state root, and then you have this 7-day challenge period where you have this like economic fault proof game where people can challenge that what was posted was actually the correct state of the world or not. And one of the biggest downsides of optimistic rollups is they have the 7-day withdrawal window. So like if you've ever deposited into an optimistic rollup, you have to wait 7 days to take your money out. And that's actually really inefficient. There's a lot of capital locked up. It also makes interoperability really like gnarly, because if you have assets on one rollup like Base and you want to use Arbitrum or something, you have to wait 7 days. And there's a bunch of like solutions that I kind of like to call infrastructure soup to like, give loans to people and do bridging and all this stuff to make it not 7 days. But it generally, the experience is pretty bad. And I think that's a really big topic of discussion in the Ethereum ecosystem right now. I think the reason those teams decided to do optimistic technology is it was just simpler to get to market faster. So ZK Tech has kind of been on this like exponential curve over the past few years, where it's every year it's gotten 10x faster, 10x cheaper, just 10x better. And so I think at the time, there were certain teams who had started building with ZK, but it just took a really long time to like build up all this expertise and build the ZK systems, because it's really complicated. And in the meantime, the optimistic rollups could go to market a lot faster. In some cases, they even went to market without fault proofs at all. But the benefit of that was like they were able to get to market, get a lot of TVL, get a lot of adoption, get dApps building. So I think overall it was like net good for Ethereum that these ecosystems were able to actually like have rollups working and running and having builders like deploying on them with cheap transaction costs. But now that, ZK is here and it's easy, it's cheap, and the developer experience is finally good with stuff like SP1 and zkVMs, I think now it seems pretty consensus that even although all those optimistic stacks should adopt ZK and transition to ZK. And actually, we've been doing like some work on that I'm like happy to dive into with OP Succinct. But I think the TLDR is just, it was easier to go to market faster. But now that the tech is like here and it's kind of like the exponential curve has played out, I think everyone will switch even in like the short term.
So I kind of want to deep dive into SP1 specifically, the choices you made building the architecture too. And I know it relies heavily on precompiles. So can you talk a bit about like what precompiles are, and especially like what kind of hash functions like it has built in, just to kind of understand like where the fastness comes from?
Yeah, for sure. So I think SP1's distinguishing feature is that it's super fast for blockchain use cases, especially rollups and bridges. And kind of what Ida was saying, why that's true is because we have this novel system of precompiles in our zkVM that make it really fast. So to dive in, maybe let's take a step back and, for example, look at EVM computation that we want to ZK prove. So when you make a ZK rollup, you want to basically prove the execution of the EVM. And that involves a lot of hashing. So in particular, the catch-up hash function, and a lot of signature verification for verifying transaction signatures. So in particular, the SecP 256 K1 curve and ECDSA signature scheme. Now, even on like your CPU, if you run like the EVM on your laptop, most of the time is actually spent doing these hash functions and these signature verifications because that's really computationally expensive. And in a ZK context, that's also true. Like if you just naively take Ethereum's EVM state transition function, you compile it, you run it in SP1, most of your proving time is spent on these hash functions and elliptic curve arithmetic. And we realized, okay, well, what if there was a way to have specialized ZK circuits for those operations, like Ketchak or SecP256K1? And basically, you can think of it as a ZK native assembly. So similar to how, like, when people hand optimize things for their computer and write assembly, you can have this like ZK native assembly for these particular really computationally intensive operations and have them talk to our main RISC-V CPU in SP1. So you kind of get the best of both worlds. You get like the general purpose flexibility of having a VM architecture that just can run any set of RISC-V instructions. But then for the computations that are really expensive, you have these specialized ZK circuits on the side that can talk to the main CPU, and you get a lot of efficiency. So to make this like really, really concrete, if you just take Ketchak and you run it in like RISC-V instructions, and RISC-V is like the underlying instruction set of our zkVM, that's like the instruction set we prove, it can take like 100,000 cycles to do a Ketchak operation. But then when you use our Ketchak precompile and you have the specialized circuit, it only takes 10,000 cycles to do the Ketchak operation. And then most of the heavy lifting is done in the circuit, which is a lot less expensive because it's really specialized for Ketchak. So you kind of get this 10x reduction in cycle count, and that directly translates to a 10x improvement in prover time. So by using these precompiles, SP1 can be an order of magnitude more efficient for these really specialized operations. And then overall, that translates to an order of magnitude efficiency in provers for stuff like the EVM for rollups, because again, most of your time is spent in these really repetitive, computationally expensive cryptography operations that we're able to accelerate with precompile.
Okay, so I'm kind of an idiot, but let me think through this. So you have precompiles within your VM that make it faster. And if we just kind of zoom out a little bit, a VM is just like a little computer that's going to do a bunch of computation. And then you're going to have this probably like expensive GPU prover that has to like create this proof. And then of like some kind of execution within your VM, you've made it 10x more efficient, but it's still probably you have like some like server in like warehouse that's making this proof. And then, but what's really cool about that is then that verification is super easy to make. Is that right? So then the proof goes out, and then anybody with consumer hardware can verify that proof is, that you did do that computation and come to that result or something like that. Am I kind of thinking of that right? That prover is going to be super expensive, probably lives in the cloud, even though you've made it super efficient with your precompiles, and then the verifier is super cheap and it lives on consumer hardware and consumers anywhere can verify it. Am I kind of getting that at the high level?
Yeah, for any ZK system, proving is generally pretty expensive, right? Like it has a lot of overhead. But then the magical part is when you verify the proof, it's very cheap. So you can like verify the proof on your mobile phone, or like it's a very inexpensive operation to do. So proving is done on GPUs or like these beefy instances. It can take a while. It can like be run on, specialized hardware, but then the proof is verified by anyone in the world very cheaply. And that's kind of like the power of ZK in general. Our precompile system just makes it much more efficient to generate proofs. So for like rollups and bridging operations and other ZK programs, previously to our system, it would take like days or basically days to generate these proofs, even if you were using GPUs and stuff. And then we basically took some magical cryptography and some clever tricks and added these like specialized circuits and made it a lot more efficient to generate proofs of EVM computation.
Neat.
I think this ties into another follow-up question is, and I didn't mention before, but SP1 is fully open sourced as well. So I believe like any developer can come in and like add a new precompile. I guess like mostly you guys have been adding it, but is that true? Like, so anyone can like go ahead and add their own precompiles?
Yeah, so SP1's architecture is fully open source, which is, I think, very needed for like security and auditability. But then also, it's really nice because teams can just add their own precompiles. So for example, say you write something in SP1 and you identify there's a performance bottleneck, you just write your own precompile to accelerate that particular function. And actually other teams have added their own precompiles. So the argument team, formerly known as Lurk, took SP1, they forked it, they added their own precompiles for BLS arithmetic, elliptic curve arithmetic, which is used in Ethereum's like blob KZG system. And that was super awesome. And we actually upstreamed their precompiles back into SP1. The Scroll team took SP1, forked it, and added their own precompiles that were specific to like their particular storage formats. And yeah, that was also accelerated their use case quite a bit. And so yeah, with open source and anyone can add their own precompiles, it's really awesome because if you have some really computationally expensive tasks, you always have like an avenue to accelerate it with our system.
Yeah, that was really like that made it very easy for me to understand like how precompiles work and why it's good to be open source. Like obviously like the auditability and security stuff as well. But one other thing, I feel like especially with open source technologies, I kind of want to it's hard to like see where the value comes from for companies as well. So can you talk a bit about like what like I know it's the prover network, but I'd love to hear from you like what kind of difference like succincts make because like I can just go and get SP1 and fork it and make my own. So can you talk a bit about like the prover network and the value add like you guys bring?
Yeah, totally. So yeah, SP1 is fully open source, so you can like go run it on your laptop. But I always like to tell people for any real meaningful use case like rollups, running it on your laptop's not going to be a fun time. Generally, like we run it on a bunch of GPUs in the cloud, and it's not even just one GPU; it's like a distributed cluster of GPUs, running in some data center somewhere. So I actually think there's like a really positive sum way like our company provides value, which is if you're a user, you want to use SP1, you're a rollup team, you're Optimism, you're running an OP stack rollup, whatever, you want to use SP1, instead of setting up your own infrastructure, you can just send us your program you want to prove, the inputs you want to prove it with, and we'll generate the proofs for you and send it back. And it runs in our cloud. We, do a lot of monitoring. We make sure that the system is working smoothly, etc. And it's super positive sum because basically we have shared infrastructure we run and we can run stuff much more efficiently than other teams, and they don't have to spend developer effort deploying their own infrastructure to run SP1. So I think like there's clear value we provide and people are like willing to pay for that value and like pay for proof generation. So we have today like a hosted prover service that most people who use SP1 actually use it through the hosted prover service. They don't run it on their laptop. They'll just send us the program. They'll send us the inputs. We generate the proofs through a hosted prover service and we send it back to them and people pay for that. And they're like super happy to pay for that. And in the longer term, we want to kind of decentralize this prover service and build a decentralized prover network where it's not only us generating proofs and sending them back, but it's more this marketplace where anyone in the world can plug in their own GPU and help contribute capacity to this like decentralized prover service that, basically anyone in the world can contribute to and get paid for generating proofs. And that's kind of like the vision of our prover network is in a similar way to how like Ethereum today provides kind of like decentralized like data availability for blobs and stuff for rollups, or decentralized like access to computation for rollups that are settling to Ethereum. We want to provide like decentralized proving services to anyone who's using SP1.
That's really cool. So you want to kind of make a transition from being like prover as a service to decentralized prover network, which is really neat to think about. That's a cool goal and a cool mission. I commend you on that. So I have kind of changing gears a little bit. You did some early work with like on-chain light clients, and you were doing like a lot of ZK proofs kind of you mentioned BLS signatures earlier and ETH validators. I have this absolute obsession with figuring out how to identify and reward solo home stakers that have their 32 ETH locked up at home, because I think they're so important for the Ethereum network. Could you, I mean, it's so hard to figure out how to do this, but I think we're getting closer and closer to having the tools. Could you use something like SP1 to build a network that proves this, maybe like an eigenlayer, like you add an extra thing to your solo validator that proves that you are a solo validator, or something random like this? This is a really open-ended question that I think probably doesn't have a solution, but I'd love to hear your thoughts on it.
It's an interesting question. I think in kind of a decentralized context, it's probably really hard to prove that you're a solo staker because like anyone who's big can just kind of like masquerade as being a bunch of small individuals. It's kind of like the Sybil resistance problem um, in another form. So I think things like, for example, WorldCoin that uses ZK technology underneath the hood, where like you scan your eye or whatever, and then you can like prove that you're a unique human, or things like ZK passport where you can prove that like, hey, I have a passport from this country, and like without revealing all your data, but just revealing like you're a unique individual that hasn't like scanned your passport before. I think ZK can be used as a tool to build other primitives to solve this like proof of humanity or like Sybil resistance problem. So SP1 can be used through that angle, but I'm not sure like SP1 directly can be used for that, if that makes sense.
There was something that you did with like graffiti. Like I think maybe it was for Noun Style. This was probably like years ago. I was like doing like
Yeah,
reading
yeah.
some stuff, but like you were able to prove that someone had a specific graffiti in a block that they had validated at some point. Like maybe
Yeah.
some combination with a graffiti proof and an IP address proof, and then some nullifier on that IP address that only one person has it. But could you use SP1 to sort of like build this system now and not have to write all your circuits?
Yeah, for sure. Like, a long time ago, we did this like proof of graffiti, where basically you prove that a certain block had graffiti, and then you can actually generate a proof that across many blocks, like over the past month of blocks, I had this particular graffiti in these blocks, and then do stuff with that. And when we built that system, we actually built it with a bunch of circuits. It took a really long time. It was super complicated. And now with SP1, it's literally a weekend project. You just take the Lighthouse client. You just can do a bunch of SSZ Merkle proofs, and it becomes really easy. And so now I think with SP1, you can start doing very complex, like provable statements across the beacon chain or Ethereum very easily. That wasn't, I mean, it was theoretically possible before, but it was very difficult. And now it just becomes a weekend project.
That's awesome. I think that's kind of the theme here is it went from you've got to know your circuits and you've got to get all your adds and multiplies and break your brain figuring out how to program cryptography. And now it's more like now you just have to write some Rust and it does what you need it to do. That's really neat. That's really cool to see kind of SP1 come together here. Another random tangent I'm on is what is OP Succinct? Like I'm assuming that is a rollup, or we're going from an optimistic rollup to a ZK rollup, or something like that. But what is OP Succinct?
Yeah, totally. Yeah, this is like the thing I'm most excited about right now that we recently put out there and launched. So kind of on the theme of like every rollup is going to be a ZK rollup. Today, if you look at all the rollups that are getting created, a significant amount of them are on the OP stack. So basically, the Optimism team, they deployed this rollup Optimism mainnet, but then they also built this really awesome open source modular stack for any other team to deploy their own rollup. And there's a lot of reasons why like teams want to deploy their own rollups. They want to have like more control over gas. They kind of want to have their own dedicated block space, whatever the reason. So a lot of teams have deployed these OP stack rollups. Now the problem is like now we have hundreds or thousands of rollups, but they all have this 7-day withdrawal period, and as I kind of was discussing before, it makes interoperability kind of nightmarish and annoying. So we were like, well, one thing that's really interesting is that OP Stack's super popular. A lot of people use it. All the rollup as a service providers support it. Wouldn't it be awesome if we could make any OP Stack rollup ZK, like fully ZKified? Instead of 7 days, you only have to wait 1 hour. So you basically have 100x improvement in finality, and you kind of get all the benefits of ZK. And with SP1, we realized that was actually really easy. So basically, we took OP Stack, and to their team's credit, it's fully open source. It's really well designed. It's super modular. And we took a Rust implementation of their state transition function, and we just took it and put it in SP1 and ran it. And then we have this like super lightweight integration where you can take any OP Stack rollup, take the proof of the state transition function, and turn it into a full ZK rollup in like 15 minutes. So it's super easy to do. And now your OP Stack rollup, instead of having to wait 7 days for finality and withdrawal, you just have 1 hour finality. So it's like much faster finality, and that's super awesome. And that was really enabled, I think, by, again, the modularity and open source nature of OP Stack, where they've made it really easy for other teams to plug in and like kind of do these upgrades and integrations with their stack. And also the power of SP1, where we could just take their Rust implementation, which they've been working on, like, because, you know, they like Rust, they're investing in the Rust ecosystem and proving it in SP1. And we were able to build that in just a month, thanks to like how easy SP1 makes ZK. And so, yeah, that's what OP Succinct does. It just makes any OP stack rollup into a ZK rollup using SP1, and you get 1 hour fast finality.
And it makes so much sense. Like now you've got this new framework or language that allows you to do this quicker. And then you spend a month and make basically the playbook of how to take your OP stack and turn it into a ZK rollup, which strategically you're thinking is probably going to happen. I would say that like, I've heard of you before, but I haven't really dug into your work. And just like going through your work in the last few hours, you were very strategic. Like each one of these moves that you have made has been very strategic and smart. And I would like not bet against you on anything. I don't even have a question. It's just like, man, if I was an investor, I would be investing in you. You were making very strategic, smart moves that like make a lot of sense with how, like what the ecosystem looks like now and also where it's going. So just like props on that. That's awesome.
Oh, thank you. That's so nice. Yeah, we're always like grinding in the Succinct office. And it's cool to see like all the pieces finally come together. Like, I think one of the things I'm most excited about is I feel like ZK has been so needed for so long. And now SP1 actually makes it easy and like simple and cheap and fast. And now it's like we can kind of put all the pieces together that everyone in Ethereum has been working on for so many years. Like OP Stack has been a years long project. They're like 20,000 commits deep into their repository. And we can take SP1, which we've been working on for a while and put a lot of hard work and like love and care into, and stick those things together. And then it's just like everyone benefits, like in Ethereum. It's like all the rollup teams building rollups benefit, the users benefit. And I think in general, like everything is about to get upgraded with ZK. Like that's kind of the power of SP1, is you can take all these existing resources and effort and compound it and plug in ZK into it really easily. So it's like I'm very much looking forward to kind of like upgrading the entire Ethereum stack like together and compounding all this effort across a bunch of different teams and ecosystems. And yeah, just like moving kind of like hopefully this having this like step function change that's kind of been like a long time in the making.
Yeah, I think it's very impressive what you accomplished in a short time. And I kind of want to ask a follow-up question for everything coming together and more like in real life use cases as well. Because I know you recently have a Succinct Residency. I think it's actually still continuing. So can you talk a bit about like both the idea behind and also the projects that come out of there? Because I feel like I've been seeing some, but I'd love to hear like what you think are like coming out of there.
Yeah, so recently we had this month-long Succinct Residency where we had a bunch of teams who are building with SP1 come to our office in San Francisco and co-work together. And it was kind of like an intense month-long hackathon. One thing that was cool to see was like there was teams from like really big companies, but also really small companies. And like it really kind of shows like anyone can really use SP1 and it provides so much value like across all parts of the stack. So for example, there were some folks from Celestia who were building with SP1 and integrating it into their like sovereign rollup framework. And so taking like ref, running it in SP1, integrating it into their rollkit stack. And now you can have an EVM like sovereign rollup on top of Celestia. So that was cool to see. They're also using like SP1 and proof recursion to build basically like a zero-shot sync of the entire history of the Celestia chain using SP1. So those were some of the projects they're working on. The Polygon team is using SP1 to build out AgLayer. So AgLayer is kind of their new protocol for Ethereum unified liquidity, fast finality. And instead of hand coding the ZK circuits, they're using SP1 to kind of accelerate their timeline. So there are some folks from the Polygon team who are building out AgLayer using SP1 at the residency, which is pretty awesome. And then you have like teams that are, you know, starting out that were smaller, that were working on things like ZK Passport, which I thought was really cool. Basically, you can generate a ZK proof of your passport, because actually it turns out your passport is signed by like some issuing authority in your of like the issuing country. and you can basically prove that you have a valid signature from like the American Passport Authority, and then you can prove like certain facts about it. So you can be like, oh, I am at least 21, or oh, I like my passport was issued on this date, or things like that, or I'm a citizen of America, without revealing like all your information. So I think that's really useful for like on-chain KYC or civil resistance or proof of humanity or things like that. So that was really cool to see. What are other things people are working on? In a similar vein, there's also ZK email, which is really cool. Basically prove facts about, you got an email, because your email is like signed by basically the email authority who you're like sending from. And so you can prove like, hey, I got an email from like the twitter.com email name server, and it proves that I have this Twitter account in this set without revealing like all the details about that. So there's this big theme of kind of moving data from like Web 2 world, like passport, email, all these types of things, to Web 3 and making it usable on chain, that I'm pretty excited about as well. So yeah, I think the two big like themes of the residency for me were like upgrading the stack. So existing large teams taking ZK, integrating into their frameworks and using it to really build and upgrade their existing products. And then kind of like nascent real world ZK use cases where it's like we're taking Web 2 data or other real world verifiable data and bringing it on chain.
Love the ZK email, ZK passport shout out. I actually just did an interview with Ayush, who is someone that we've been funding since long before he was picked up by PSE. And like it kind of came down to in the conversation that like build guild grants, like our little build guild grants, were enough to like keep him going during that time between kind of 0x Park and PSE. But kind of zooming in on that, 0x Park and their influence and impact on the ZK space is immeasurable, right? And it sounds like you met your co-founder John in a 0x Park residency, and probably some of your like early engineers. But now you've kind of become a company, people know about you. It's probably your hiring is changing a little bit. So if I was a decent Rust developer, and I may not know a ton about circuits, or maybe I do, and I want to come work for you because I can tell how awesome you guys are at product thinking and how strategic you are. So if I'm a super nerd and I didn't meet you early in the early 0x Park days, how do I get your attention now? How do I come join and work for you? Like, what are you looking for in terms of how you hire people? Like, what do I do to get your attention, basically? Send you my GitHub?
Yeah, I mean, we're always looking for like really strong Rust engineers who are like passionate about this stuff. And like, yeah, actually, like I love 0x Park. I know the founder before I was even into crypto. Actually, he got me into ZK. We met at school when I went to MIT. And yeah, I met my co-founder at 0x Park, and the 0x Park residency was like where I learned a lot about ZK and like really got into this space and like started diving deep into it. So yeah, shout out to them. They've like onboarded a lot of people onto the ZK and really spread like the ZK gospel. In terms of like hiring, I think we're always trying to like work with like the best people and people who are like really passionate about, building all this stuff. Yeah, building SP1's like a lot of really hard work, and it's really quite fun too, because I think especially for people who are obsessed with like performance or optimization, you have this really concrete number, which is like how fast can we prove stuff, and you can just like optimize it and see the number going up, and that's always like really exciting to have that feedback loop. There's also a lot of other like a lot of people on our team, when they join, they actually know nothing about ZK. Like, they're just really smart, really motivated, very talented engineers. And we actually like the stuff we're doing, I think, is so at the frontier that we actually teach people, and we all learn together in building all this stuff. And like we actually have like a cryptography boot camp that most new hires like go through, and they learn about like SP1, how it works, like cryptography basics, stuff like that. So I think like people on our team, like they can go from 0 to 100 really, really quickly, because yeah, there's like a really strong emphasis on learning. In terms of like, reaching out to us, like we're always looking for really strong people. So yeah, like sending your GitHub, and like, especially if you're like really passionate about open source and have done a bunch of open source work before, that's always super awesome. Or, just like interest in like writing about ZK stuff. For example, I think Ida has like a really amazing blog with a lot of like ZK, like intro to ZK, or like explaining ZK from first principles, that I thought was like super awesome and was super impressive. So yeah, I think there's a lot of ways to stand out, just like open source work, existing writing, your GitHub, like, how green your graph is, like, the passion for this stuff. Yeah.
Can I
Thank you
also throw in a
go for
shill?
it.
I want to throw in a shill for speedrun Ethereum too, especially Uma, if you have folks inside of you said that sometimes people join without any ZK knowledge. If they join without any Solidity and smart contract knowledge, and they're going to be writing some smart contracts, tell them to speedrun Ethereum at speedrunethereum.com. Shill. Okay, I'm done.
Oh yeah, I've used that myself before when I was getting into this space. So yeah, I remember
Amazing.
like reading Austin Griffith's like hard hat tutorial back in the day.
That's
Love
super
it, love
nice.
it.
I think we're getting better at shilling, but thank you so much for the shout out too. I really appreciate it. That's very kind. So I think we talked a lot about how zkVMs and SP1 makes it easy for developers to come in, but I kind of also want to talk a bit about like maybe the challenging parts or the trade-offs. So are there like any so I yeah, do you think there are like any trade-offs that are worth mentioning when you kind of go and start building with SP1? Yeah, just it feels like very you can just go in, start using Rust, but I'm curious to see if they're like maybe you see like some stuff which you guys are working on at the moment and that's not yet built yet, especially I feel like with
Hmm.
smaller teams like being built right now, it's like kind of hard to follow along because you need to like constantly get the new version. But yeah, just kind of wondering the trade-offs for developers.
Yeah. I mean, I'm kind of a zkVM maxi, honestly. So I think all of ZK in the future is going to go through zkVMs. In terms of trade-offs, for example, for things like rollups or bridges, I think the best way to build it is genuinely with SP1. Like we as a team built a bunch of ZK-like clients before. So basically taking consensus protocols, implementing them in circuits. And our performance with SP1 is faster, cheaper, and way better developer experience than any of our circuit stuff. Like very concretely, for example, we had a Tendermint like client we implemented in Plonky 2. It took tens of minutes to prove. It took several dollars to generate a proof. It took us months to develop. It was like 3,000 lines of code. It cost $30,000 to audit. Like it was very expensive. And in SP1, it's 300 lines of code because we just used the Tendermint Rust scrape. It took an intern on our team like a day or something like that, which I kind of was like, oh wow, like I spent 3 months of my life building this stuff and our intern did it in a day. So that was pretty awesome to even for me personally to see. And generating proof costs like cents and it's really fast. It's like, less than a minute. And I think you might be like, well, really, like, how is it that you have there's no downsides? And the reason for that is because SP1 is so general, we can spend so much engineering effort optimizing it. So we run it on GPUs. Like every morning we wake up and we're like optimizing every last nook and cranny for, performance improvements. And I think fundamentally it's kind of like we finally found the right abstraction of building these systems. And when you have this really general platform that's used by like many, many teams, like 50 or probably 50 or more teams use SP1, you can just iterate much more quickly and get a better feedback loop and invest more engineering resources to make it a lot more performant. So that's kind of my intuition for why I'm a zkVM maxi. It's actually really grounded from like personal experience and seeing how much better it is in every dimension versus the old circuit paradigm. Because in our old circuit paradigm, we would never have the engineering resources to take one application and put it on GPU. It just like wouldn't make sense from an ROI perspective. But with SP1, it makes all the sense in the world to improve it because it helps all of our customers who are like a bunch of different use cases, a bunch of different ecosystems, whatever. So I think today, probably the biggest downside of SP1 is that if you want to run it on your phone and you have like a phone that has like 2 gigs of RAM, it's not that good at that. So I think for client-side proving use cases, right now, SP1 is still worse than like handwriting a custom circuit in certain use cases. And we're really actively actually working on that. We have like a big internal effort to like improve client-side proving and mobile proving and stuff like that. Because I think that's kind of like the future of privacy and a really interesting unlock for ZK applications like ZK Passport and ZK Email. So today, I think SP1's a little worse for client-side ZK because we really optimized it for server-side proving for these like really big, beefy computations like rollups and like clients. And so, yeah, really active area of focus for us right now is actually like being better than circuits for client-side proving. And I'm fully confident we'll be able to do that. Like, we just need to optimize for that use case. But that's maybe one of the trade-offs we have today. Yeah, but other than that, I think for a ZK rollup, it's like zkVM is just the future. And I think that's becoming more and more of like a consensus view.
Yeah, and it feels like you did the hard work for us to make it easy to use. So it's the architecture choices which make it actually like very performant and kind of give those benefits. So one other question I wasn't I guess I'm trying to also ask like the bottlenecks of like how do you see it being used today? Like what are you focusing on like building right now? Because I feel like you built like a highly performant SP1 and you want more people to use it. So curious to see like what are the bottlenecks? Like I guess with especially like OP Succinct and like I know you made a lot of partnerships recently. So curious to see like what you see are the like your main focuses right now, considering you have like a very high performant machine.
Yeah. I mean, honestly, like we're always working on making SP1 faster and cheaper and better. And we have like a long laundry list of ideas on how to do that, ranging from like cryptography to like just better GPU implementations to like, better distributed system implementation. So both at the cryptography and engineering layer. And if you're interested in working on any of that stuff, it's actually really fun. And it's almost addictive because it's like you just see like this number go up. And yeah, so if anyone's like looking to work on that stuff, please reach out and like apply, and would love to chat. So making SP1 more performant and fast and cheap is a big priority. And then also just broadly adoption. Like I think we did this OP Succinct integration so that any rollup can now be a ZK rollup using SP1. And there's a lot of dev nets that we have that are proving, and hopefully we'll take some of them to mainnet soon. So I think that's been really exciting. We are looking to kind of integrate with like all the other stacks as well. So really on this mission of making every rollup a ZK rollup, also making Ethereum interoperability better with ZK broadly. So I think like, any large protocol that wants to use ZK, whether it's Polygon for ag layer or, any of these other sorts of constructions, we really just want to be there and enable them to adopt SP1 and use it. Like, I think the tech is ready, it's cheap, it's fast, it's actually easy to use. And now like we have to help teams actually integrate it end to end. And often in their integration, like the easiest part is actually the SP1 part, because it is really like you just write Rust and you use it. The hard part is like designing your protocol and integrating systems end to end and getting the tests working and blah, blah, blah. So just helping teams like through that broader journey of upgrading their protocol to be like ZK first is kind of another big focus of our team.
Seems like you're doing it right, though. Again, strategy is great. I think you've put like everything in place for that to happen. So I think that's happening. So okay, my last question. It might be a little bit of a hot take. So based rollups are getting steam, at least in my feed. I'm hearing Justin Drake talk about them. They probably use ZK and put stuff on chain anyways. But like, hot or not, based rollups. What do you think?
Yeah, I think base rollups have been popular. I think for me, I'm like a super product and like user centric person and thinker. So it's like, what problem is based rollup solving for our users and our community? And I think that's like the key question that needs to be answered. Now, for example, I think one concrete problem base rollup solve is decentralized sequencing, because you just submit transactions to the base layer and you automatically get like a decentralized sequencer for free. So I think for really for use cases where censorship resistance is really important, maybe base rollups solve a real problem and make a lot of sense. And I think in those contexts, the base rollup teams should really focus on like use cases where there's clear benefit from like the value they bring and the censorship resistance. I think for a lot of applications though, like having the current centralized sequencers is actually like totally fine. And for example, you see teams like MegaETH even tout the fact that like we don't have to go through consensus is really powerful, right? It's like we don't have to have the overhead of consensus, so we can actually have real-time latency and like really fast block times and really, really high performance. And yeah, I think that's also pretty awesome as an architectural decision. So for me, yeah, I think for the base rollup stuff, I would say it's important for those teams to focus on like what's the end value to like the application or the user or the customer that my architecture uniquely enables. And I think there are some real answers there in terms of censorship resistance. So yeah, it's just like a matter of emphasizing that and finding the people who benefit from it.
I think we're almost on time. So Uma, it was very nice to chat with you today. I've been interested in SP1 for quite a while, but it was great to like pick your head on like a few topics which we had questions on. So as we're getting to the end, do you have like any call outs, like call to actions, like to anyone listening? Where can people find you? And thank you again for being with us today.
Yeah, for sure. So yeah, I mean, you can find us on Twitter at Succinct Labs, or my personal accounts at Puma the Uma. You can check out our docs.succinct.xyz. And also like for everyone building with SP1, we love it when they like reach out and tell us about what they're building so we can provide them with extra support. So yeah, if you go to our website, succinct.xyz, there's like a get in touch with us. And yeah, we're always like happy to talk to SP1 users. And yeah, we're always like hiring for really talented like Rust people, or even if you don't know Rust, or you're just like interested in ZK, you're passionate about performance. I think everyone on our team like learns a lot. So yeah, you don't need any prior experience. I think like sometimes people are scared to apply almost because they don't know anything about ZK, but that's actually totally fine. We're just looking for like really smart, hardworking, passionate people. And yeah, it's super fun. The things we're doing are so interesting. There's so much math, there's so much cryptography, there's so much just like stuff to do. And we're hiring for like a bunch of different roles kind of like across the stack. So yeah, you can just like apply on our website. There's like a link to our jobs, and yeah.
And it's in person too, right? You run a in-house shop in San Francisco. Do you have any remote workers, or is it all everyone's got to be in the office?
Most people at our company do work in person in San Francisco, and that's also really fun because like we'll just it's always fun to like collaborate together, whiteboard, like hang out, you know, at lunch, like after work stuff. And I think that's also like why people learn so fast. It's just like the in-person learning is like unparalleled, honestly. We do have some remote people though, in America and also even outside of America. So yeah, that's not like a blocker. But yeah, I think a lot of people enjoy working in person. So yeah.
Perfect. Yeah. Well, I mean, I guess you can probably tell that Austin and I are quite a fan. So thank you so much, Uma. And yeah, see you sometime in real life, hopefully. Bye, everyone.
Yeah, for sure. Thanks for having me.
Thank you, Uma.